Good evening, Namaskar, Jai Shri Ram. You are welcome to my channel Learn Statistics using R from Akhilesh, where we present a series of lectures on statistical methods with statistical computing using R. Today's episode is 5th, and the topic is some common graphic presentations of data. In the episode 4, we discussed some common diagrammatic presentations of data. Today we shall be discussing graphic presentations of data. Instructor is me, that is Dr. Akhileshsingh. I have been a professor and head of agriculture statistics before retirement in the Department of Agriculture Statistics in Indira Gandhi Agriculture University, Raipur, India. Today's presentation involves, as I told you, some common graphic representations of data. What is the difference between diagrammatic representation and graphic representation? A diagrammatic representation mostly pertains to discrete and character type of data. We have already discussed in the previous lecture. Graphic presentations mostly pertain to continuous type of data. We shall be discussing this type of presentation in the today's lecture. The first is column bar diagram. Column bar graph is also said representation data. Basically it is graph. A column bar diagram, as generally is told, but it is a basically graph, is a two-dimensional graph in which distinct variable values are plotted on the x-axis, whereas frequency is plotted on the y-axis. It is like a thin vertical bar plot, but with a difference. It is not a bar plot. We'll come to know after we compute it. Bar plot is unidimensional diagram, whereas column bar diagram or the graph is a two-dimensional graph. It is the basic difference. It is useful for discrete data types, whereas bar diagrams were generally used for character data types and time series. Column bar diagram, let us compute for the Tagore world data. You know this data we have already discussed many times. This is how we take it in the RStudio and compute. This is the computations we have already done. Need not to repeat again. This is how we find the frequency distribution. We have discussed in earlier classes. Based on this frequency distribution, we shall be creating column bar diagram, where these x variable will have the length of the bars according to the length of the frequencies. This is that. Plotting column bar diagram. Here what we do, we take the width function, with this data frame. You see this data frame we have already created, where it contains two columns, capital X and small f. Okay, we need to access this X and F columns. So for that we will give this data command with this data frame we want to work, where this will enable us to directly access the X and F columns. So there is another function, plot function. First time we are using it, and this is very important and very versatile function in base R. We have to give X and Y coordinates. X coordinate is given by capital X with this frequency distribution data frame, this one. Okay, so we want to carry that capital X from here, and then Y equal to F from here. Okay, now type is very important. Type means type of plot function actually determines many type of plots. Type H is kind of histogram but not histogram. We'll come to histogram later on. H for histogram, just for your remembrance you can learn. This is the main title, column bar diagram. X lab means X label, Y label, Color is blue, that we have already taken. Let me take you to the computation part. You see, in this computation part, what we have done so far is we have created this frequency distribution. You see that I have discussed there. Then I am just creating this column bar diagram. Okay, let us come back to our presentation. So you can see that this column bar diagram contains vertical thin bars drawn above the discrete word length values whose heights represent respective frequencies of word length. Let me show you again to the another one. Here you see, this is again 2-axis data, 2-dimensional data. These are column bars, column bar graph, and this is a thin vertical line, not like a bar diagram, bar plot diagram that we have already discussed in earlier lectures. Coming back to our presentation. Next, for further types of graphs, let us compute cumulative frequencies. So these are the frequencies we have already, computations we have done. So I will not repeat them here, just for your presentation I have brought it here. And then we have prepared this X, F and relative frequency, and although I am not presenting relative frequency here, because we can do a similar graph just like we are doing, we can do a similar graph of relative frequency just like we are doing for frequency. So I am not discussing it here. I am discussing cumulative frequency of less than type, greater than type, for which we have separate graphs. We call them step diagram. What is a step diagram? It is a 2-dimensional graph in which distinct discrete values are plotted on x-axis, whereas cumulative frequency of less than type or more than type is plotted on y-axis. It looks like steps of staircase, which suggests its name. It is useful for discrete type of data. The step-like structure has some logic behind it that I will discuss you a bit later. Next, since for the discrete data there are no intermediate values. Remember, we have discussed this concept while we discussed data types on one of my earlier lectures. So according to that, for discrete data there are no intermediate values between the distinct values of the variable. Therefore, when the cumulation of frequency, cumulation means gradually adding up of the frequencies take place, it will have a sudden jump at the next distinct value equal to the amount of the frequency there, and so on. I will just show you how and what do I mean by it. Although I have not computed it, but I will show you what do we mean by sudden jump. This is the step diagram that we shall be computing a bit later. You see, since this is a discrete case and discrete doesn't have any the intermediate values, so from 0 to 1 this line, this horizontal line indicates that there is no increase, because in between there does not exist any value. Then from 1 to 2, again at 1 a little jump is there. 1 to 2 again flat line, because there is no intermediate value. Then at 2 this takes a sudden jump, then a flat line, because up to 3 there is no intermediate value. On 3 it jumps with the amount of frequency equal to the amount of frequency. Then after 3 up to 4, up to 3 this will have flat values, then at 4 it will have a sudden jump. This is that concept that I was telling you. This is due to discrete kind of discrete nature of the data that I was just hinting at here. Now let me compute the step diagrams. So let us start with the ascending step diagram or graph. There is descending also. This I was just telling you, and I was just discussing about the jump of the frequencies. plotting the ascending step diagram. Again, with function we will plot, and we'll have x is same, but y is now not f, it is cumulative frequency of less than type. And remember, the type is very important. In the previous one the type was h for the column bar diagram. Here the type is s, small s. So ascending step diagram, word length, x level, y level, and so on. Let me demonstrate you in the RStudio, where you see these are the computations we need actually for the computation further. This is that step diagram. Okay. Now coming back to our presentation. Computation of step diagram, descending type. This is descending type. What we do, there is no change in the from the previous one, except that the y value is now upper one. Okay, and we can show it in the RStudio also. In RStudio, see, this is the descending type. Okay, coming back to our presentation. Now next is crossed ascending descending step diagram. In the crossed ascending descending, what we have is the ascending as well as descending both on the same graph. How do we achieve that? This is the similar command, but with a difference. We type the less than type first, ascending, but we change the title, ascending and descending both, because although this will plot the ascending, but the latter one will plot the descending one. Okay, so the second one is, this is the high level plotting function, plot. This lines is the low level plotting function. This high level and low level plotting function, about which I have already discussed in the previous lecture. So in the lines we take upper frequency, upper cumulative frequency. Type is same, although I changed the color. Here it was, the color was blue, here I have changed the red to differentiate between them. Now I shall take you to the RStudio, where we shall compute it again. You see, this is our ascending, descending both, but in particular now this is ascending. Now the latter lines command gives us descending diagram, step diagram. Okay, now I shall be taking you to the discussion part, where you see these are all two axis diagrams, sudden jump, this is sudden downwards jump, this is upward jumps, both are two axis diagrams. This is step diagram of less than type, this is step diagram more than type, but when we cross it, we have a step diagram of less or more than type on the same graph. Note that the crossing point is nothing but it is corresponding to the median at the x-axis. This is x-axis, this x-axis. Here the median value is 5, so it indicates 5. The crossing point actually takes place at the median value of word length, which is 5 here. Okay, now coming back to our presentation. Now students may note that the cross point of the two ascending diagram and descending step diagram corresponds to median on the x-axis. Histogram graph representation of Indian adult males. Now we shall be discussing some plots on the continuous data. So far we have discussed the graph representation for the discrete. Now we shall be discussing the continuous data types of graphs. Starting with histogram, which is very famous. A histogram graph is a two-dimensional graph in which continuous variable values are plotted on an x-axis as class intervals. On the x-axis, class intervals are plotted, whereas frequency or probability is plotted on y-axis. It looks like a series of bars but it is not a bar plot, remember. It is useful for continuous data types. Its structure is like a set of contiguous, not continuous, contiguous, nearby each other. Contiguous means nearby each other, adjoining each other. So continuous vertical bars erected over corresponding class intervals. I'll show you how. Let me briefly go to there, and I'll show you there. This is histogram. What we mean, these are contiguous bars. They are adjoining each other, and rectangle kind of thing. Any vertical bars are erected over these class interval. This is one class interval. This is another class interval. This is another class interval. This is another class interval, and so on. You see, on every class interval there is a rectangular or vertical bar is erected. So let me go to our presentation. So this is what we mean continuous vertical bars erected over the corresponding class intervals. Since for continuous data there are no distinct values, rather the values exist only in the interval of values. This is in contrast to discrete data type. In discrete data type there are distinct values, but in the continuous there is no distinct values. Values exist only in the interval of values, and the vertical bars are erected over the class interval, which are contiguous. Joining the midpoints of top vertical bars, the resulting sketch becomes a curve on the concept that there may be infinite number of values within any given class interval of values. What do we mean? We mean by it, let me go to there. Beforehand I will show you, when we join the midpoints, these are the midpoints. If we join the midpoints of these vertical bars, midpoints corresponding to mid values of the class intervals, then we have a curve. This is what we mean. But if we reduce these class intervals infinitely, these joining of the curves points and the lines in the sketch will tend to become a curve. This is the concept behind the frequency curve. I'll come a bit later. Okay, coming back to our presentation. This is what I said. The joining the midpoints of top vertical bars, the resulting sketch becomes a curve on the concept. The concept is that there may be infinite number of values within any given class intervals. In histogram, the y-axis is designated as frequency if all class intervals are of equal class width. What I mean? These class intervals are equal, but sometimes they may not be equal. I have not taken the example here, but sometimes they may not be equal. When they are not equal, then this is that case is this one. When they are equal, this case is this one. I mean, when the class intervals are not equal, then there is a probability. I shall come there in the presentation also. You see, here is a probability in the red ellipse. In the red ellipse here you see frequency. In the red ellipse we see here probability. So when it is probability, when it is frequency, it is for equal class interval case. But when it is unequal, although they are equal here, but it is ideally for unequal class intervals. In that case, the y-axis become probability. Let me go to presentation. So this is what I was saying. Okay. For equal class width, we designate frequency in the y-axis. However, if all the class intervals are of unequal class width, I had just discussed about that, y-axis is designated as probability, in which case the areas of continuous variables are represented as frequencies. What do I mean is, in this yellow graph, you see, I have indicated by green lines these shadows. This means total area, all these total areas are equal to 1. But when we take a class interval corresponding to this, a vertical bar is there and the area of this particular bar is actually the probability corresponding to this class interval, and similarly for other class intervals. This is the basic difference between this probability and basic frequency concept. In the frequency concept, only height matters. These width of the bars does not matter. Whereas in the probability case, probability histogram, these do matter because it belongs to unequal class width case, and here the area do matter, and those area for respective class intervals indicate the probabilities for those class intervals, and the total area corresponds to the total frequency, that is 1. Let me go to presentation. So heights of vertical bars are represented as probability densities. So what did I mean is, here in the yellow graph, you see this height is probability density, whereas here the height is frequency. Here the height is probability density, and when we integrate over these densities, we get the area. This is what I meant there. Okay. Areas of vertical bars, rectangles, are represented as probabilities corresponding to class intervals when the y-axis is designated as probability. Let us now compute for the Indian adult height of 177 males. This is a continuous data, very standard one. I shall be taking, we have already taken this data many times. This time also we shall be taking. Now I have now plotted the histogram. How? This is very simple. A histogram is plotted by hist function, and where it takes the original data. We do not actually need the previous data of the frequency distribution. We need the original X data. How do we do it? And main frequency histogram. This frequency is not probability histogram. And X level is height, Y level is frequency. Color I have taken light blue. Let me go to the RStudio to demonstrate the same. Now coming back to this Indian adult height, and if we enter it, control enter it, we get the data in the memory, and then we hist function plots it. This is what the code I was discussing. Now coming back to our presentation. Next, plotting probability density. What is the difference between the earlier, this is a frequency plot, this is the probability density plot or probability plot. What we are doing, everything is same except that this parameter. We are say probability is true. In the previous one we do, there is no probability true. That means that by default that the probability is false. Here probability true. That means the hist function will plot probability on the y-axis, and similarly these will have the, you see this ranges from 0 to 1 maximum, whereas in this case this ranges from 0 to maximum frequency. Okay, so this is the difference, and we have already discussed in the this one also, and you see we have already discussed this. Okay, now coming back to presentation. Now there is a frequency curve graph representation of data. What is definition? A frequency curve graph is a two-dimensional graph in which continuous variable values are plotted on x-axis, whereas relative frequency probability is plotted on the y-axis. Remember, the probability is nothing but a relative frequency in the statistical sense. Okay, is plotted on the y-axis. Its concept emanates. Emanates means comes from the concept of infinite values. Its concept emanates from the concept of infinite values in the class interval. We have already many times said that there may be infinite values in the class intervals. So it comes from that concept. In the infinite values there may be in the class interval there may be infinite value. In the sense what? In the sense that if the widths of the class intervals tend to get reduced infinitely. This is a very important concept. Let me go to our this presentation. Here I shall tell you. This is the class interval. Okay. Suppose there is an example where of the same we increase the size of the Indian adult males sample, and thereby what will have, that we will have reduced class interval sizes because there will be more data. So if we do this, increase the Indian adult males sample from 177 to higher up, say 500, 1000, 2000, 3000, 4000, 5000 and so on. If we go on increasing the total frequency of the sample, and thereby automatically these will get reduced and infinite values will be coming up in the example. And when these get reduced, then these sketch values, I mean what I mean is you see, when we do this, join this and this and this and this, then this is a kind of rough sketch. But when the these class widths will be reduced, it will simply try to become a curve kind of structure. Okay, this is what I mean by this discussion. Okay, coming back to our presentation. This emanates from the concept of infinite values in the class interval, in the sense that the widths of the class interval tend to get reduced infinitely by increasing the sample values infinitely. So this is the frequency curve we compute. How? For frequency curve we need to generate a large, practically large number of coordinates of x and y both. How do we do? There is a density function. What we do is the values that we have x, we apply density function of these values. So R automatically creates a kind of similar values that is not in the actual population, but it simulates them as a similar values, and let us see that it is stored in high density. What happens? Here I need to go to RStudio. You see here, this one we have already computed. Now this is what I mean to say. You see, high density has been computed. You see in the console I have stored height data in height den. What is this? You see, I have computed density of x. What is x? X is this. Okay, so we have applied this. X is this, and on that a density function is applied, and its value is stored in x den, height den. What I see in height den, we have this value. We do not understand anything here, but I'll tell you how. How will we get height? Let height den, and then dollar, and then x. What do I mean is, from this list of data, I want this x value, this x, not this x, this x value. Okay, this x value is joined by dollar sign. This means that x values from the height den list of data. What does it give? It gives a very large number of 512 values, 512 values that are automatically computed based on these by simulation method. Okay, I will not discuss about simulation. You search somewhere. It is just similar kind of computation. Similarly, if you see there, it has some y values also. It has some y values also. So if we just say the height den, what is the y values in the height den? These are the high value. These are actually the y coordinates, and these are the x coordinates. X, y coordinates, that's we have x, y coordinates necessary for the computation. Let me go to our presentation. So here when we do have height, then already have those x and y values within it. So what I do, I have shown in the RStudio what x and y values do have, but here we don't need them. We simply tell it that my x coordinate is height then $x and y coordinate is height then $y. That's all. And remember, type is else. You should take type, line type. Okay. And this is a frequency curve of heights of Indian adult males, x level height, and this is probability. Remember, in the frequency curve, although it is said to be frequency curve, but the y-axis is always probability, because this comes from the emanation of infinite number of values within the class intervals concept. Okay, so this is how we plot the frequency curve. Now we can also plot frequency curve over the histogram, because these frequency curve are basically they belong to the same class intervals. Simply they have been obtained by simulating, conceptually increasing infinitely the values of the values using density function. So here again we compute it, and then we apply hist function. We have already computed histogram by putting the probability true here. Next we apply lines command. Remember, in this we again give height then x, height then y as the coordinate values of x and y. Color red to just to differentiate the color. Remember, in the previous plot we have used the high level function itself, because we didn't need any lower type of functions, lower type of plotting. Here we need both high level using hist and low level as frequency curve in the form of lines. So this is how we do. And if we go to our RStudio, you see that how does it do. So density we have already computed. This is for the next ones. This is how we obtain there, and in the further discussion part we can say that this is how we have done. Okay, we have discussed all the aspects of it. Okay, now coming back to our presentation. For further types of graphs, for continuous type of data, let us compute cumulative frequencies, etc. These computations we need them here. We have already discussed about them in the previous lectures, so we will not discuss it here further in detail. Simply just showing you that these are the values we have already computed in our previous one of the previous lectures. I am just recapitulating them because we need them here. Okay, now ogive curves graph, the computations that we have just shown will be needed here. What are the ogive curves? These are actually given a technical term name. They are cumulative frequency for the continuous type of data. An ogive curve is a two-dimensional graph in which continuous interval values are plotted on x-axis, whereas cumulative frequency of less or more than types are plotted on the y-axis. So we can also say it as a cumulative frequency graph for the continuous data. It look like curves, and these are given special names ogives. It is useful for continuous type of data. Since for the continuous type of data there are no distinct values between the two limits of class intervals of the variable, therefore when the cumulation of the frequencies take place, corresponding cumulative frequencies of less than type, it will continuously cumulate from the upper limit of the class interval downwards. We have discussed in one of the other type of data types. In that I had discussed what do we mean by the cumulative frequency of less than type, in which we understand the cumulation of the frequencies from the upper class boundary or upper limit. That is what I am indicating it here. However, when the cumulation of frequencies take place corresponding to cumulative frequency of more than type, it will accumulate from the lower limit. Here opposite relationship is there. For the cumulative frequency of less than type, we have upper limit downwards. For the cumulative frequency of more than type, the cumulation will take place from lower limit of the class word upward. Okay. What do we mean by it? I'll just show you in the demonstration. When cumulation takes place, cumulation of the frequencies of this and this. When we see cumulative frequency of less than type, for example from here, so what I mean, from the upper limit, all the frequencies will be added on the downward side. For the cumulative frequency of more than type, from this class interval, we say this from the lower limit of this class, from the lower limit of upward. So this is what I am saying there. Okay. Now let us compute the ogive curve, ascending type ogive curve, that is from the increasing. This is based on the cumulative frequency of less than type. So that is why we put a cumulative frequency of less than type here. But remember, this x value is upper. I just discussed it here. For the cumulative frequency of less than type, we need upper limit of the class interval. For the cumulative frequency of more than type, we need lower limit of the class interval. So that is reflected here. Okay. You see, x value is upper limit of the class. Where we do get it? We get it from here, from the previous computations. You see this one. Okay. Going back. So therefrom we get this one. You see this width frequency distribution I am saying. So from that data frame we will get U and CFL both. Type is L because we want to have line type of graphs. And this is cumulative frequency of less than type, you see, I have seen here. And this is what we can obtain in the RStudio also. You see, these are the computations that I will not discuss them. This is from the previous lectures, and this is what I am computing as full frequencies. And then now this is the plot ogive curve of ascending type. Okay, and when we see it there in the further demonstration, we find it here, this one. Again 2 axis ascending ogive curve of cumulative frequency of less than type. Okay, now coming back to our presentation. Ogive curve for the more than type and descending type. Here we reverse the roles. This becomes L, that is lower than type. I have discussed it that this is the opposite relationship, and this is cumulative frequency of more than type. The rest things are same, and you can go to the RStudio where we see that if we, you see this is a descending type of this one, and in the demonstration also, and we see that this is the ascending and descending both. Okay, now coming back to our presentation. Here now we will plot the crossed ascending and descending. So what we do with frequency distribution, we first plot the ascending one, the other one we plot with the lines. This is the same technique we used for the discrete data type. So for the ascending, we see upper limit and lower class cumulative frequency of less than type, and here we have the opposite, this L lower limit, and this is upper cumulative frequency upper than type. Okay, and in the RStudio we can do this like this. Okay, and you see this is how the second is prepared by this one. Okay, so let me go to our and in the demonstration also we see it there. This is the cross point always belongs to the median point. This corresponds to this 165, almost 165 median, this cross point. Okay, now let me go to our presentation. So now Students may note that the cross points of the two ascending ogive curve and descending ogive curve corresponds to median of the x-axis. So this is all about today's lecture, and now I shall be finishing my lecture. Thank you, and I wish that you will like, subscribe and share the video if you like my lecture. Thank you. Jai Shri Ram, Jai Shri Krishna, Namaskar, good evening.